introduction to the transport layer. After that, we'll do some in-class activities, video case. Then we'll have a break. And after the break, there is a presentation. Group 6, I believe, is presenting. And we will also do more activities after that. We will also take the attendance after the break, so please stay because we will have a presentation and do some video cases in the class. So going back to our network model, so far we have seen the physical layer, which was the first layer in our model. The unit for the physical layer was bits, right? Just a stream of zeros and ones. In the second layer, it was the data link layer, where we have seen that we can connect two computers, one at one end of the wire and another one at the other end of the wire, which are able to exchange information in the form of frames. The unit which data link layer produced was frame. So after that, we have seen the network layer, which allows us to connect computers that are not only directly connected via a cable or wirelessly, but they could be anywhere in the world. In other words, we can connect to computers with we can have two computers exchange data which have multiple hubs or routers or entire networks in between them. And the unit which the network layer produces, do you remember what it's called?
Packets.
Packets. So we were attaching a header to the message, which was the Internet Protocol header, IP header, and as soon as we touch that, the unit becomes a packet. And the next layer that we will look at is called the transport layer. So if we are able, and the unit which the transport layer produces is called a segment. Now, on the top of that is the application layer. So the application layer directly communicates with the transport layer. So this was our network model. The purpose of the transport layer is to provide service to the application layer. So if we are able to do all these things, we can connect two computers together. They can exchange data through packets, and no matter where they are in the world. This is the application layer data unit. Then why do we need the transport layer?
Because we have different networks. Maybe like there is like only one network where we can always use that. Maybe we don't need maybe transport layer because everything is in that it's only one network we can use.
Okay, so with the network layer, when we had data link, they had the two computers had to be directly connected to each other. From one end to the wire to the other end, we can send these frames. With network layer, we added additional logic, which we have these routers and links, and we have stored information about the topology or geographical physical location of all the routers and links, and we can route packets anywhere through different networks until it reaches destination. The network layer adjusted to the properties of networks, but why do we need the transport layer then?
You need to transport the packets anyway. You can provide a way of doing that.
We had a very beautiful figure in one of the previous PowerPoints which showed the bottom three layers were outside of our control. They were owned by the internet service providers' equipment. So we had no control over them. If there is some issue, then there's nothing we can do. But in the upper layers, such as the transport layer, we are able to make changes and implement our own programs. Another reason why we need this layer is because so remember, these are the layers that we have, and then there is this oval box here around the physical layer, data link layer, network layer. So these three layers are sitting in this box called communication subnet boundary. And the reason they're sitting there is because these are controlled by the internet service providers, and we as the users have no control over these layers. So whatever is going on here is up to the internet service providers, and there's nothing we can do. But in the layers above, the transport and the application are running on the user's machine. And we have the ability to do some programming and change parts of the functionalities of transport and application layer. Why would we want to do something like this? Another reason why we have transport layer is because in the network layer, we had no guarantee that the packet will be delivered. So we are able to send packets from source to destination anywhere in the world, and we have these routers computing the shortest path and the best way for the packets to get there, routing them. But there's no guarantee. They are doing best effort service. If it works most of the time, but sometimes it doesn't work. And if it doesn't work, there's nothing we can do if we only have these three layers. The packet will be lost. So, why would it not work? Could you think of any reasons of why a packet would not be delivered through the network layer?
Maybe some of the routers down, maybe, I don't know, like some kind of could be.
If one of the routers is down, what will happen? The routing tables will be updated, right? And the packet will take it on a different route to avoid the router which is down. Is there another reason?
Maybe like,
Congestion.
How about the group that is about to present? They just said congestion. Their presentation is on congestion control. So let's say there are too many packets on one of the links, and the router is getting swamped with packets that it has to route, and it cannot handle all of that. What is it gonna do?
Drop.
It's just gonna drop some of them. It'll discard them. That's one of the easiest way to handle congestion. It'll drop them. And when it drops them, they're lost. Unless we implement some logic in transport layer to track these packets, receive acknowledgements for them. If we don't receive acknowledgements, then we reset them and have some tracking functionality implemented to make sure that the packets are delivered and provide some guarantee. So that's another major reason why we need this layer. So in this layer, we would establish connections between the sender and the receiver, and through this connection, all the bits and pieces of each packet will be tracked. And is it possible that, let's say, we have 4 pieces in the packet. One of the pieces arrived fine. The second piece is taking too long because it took us some faraway path because some of the routers were down. The third piece arrived, and the fourth piece arrived. So the receiving side will get pieces 1, 3, and 4, and the second one is missing, which means it has to be resent. So it will get it, but out of order. It will get 1, 3, 4, 2. What? So this layer is responsible for arranging them back into the correct order to assemble the original piece, the original packet. So basically, this layer provides us the guarantee that the network layer could not provide.
Is it similar to insurance?
Pretty much, yes. Once we have this layer, we can guarantee that the packets will make it there and that they will make it in the correct order. So, the primary function of transport layer is to provide service to the application layer. So every layer provides service to the layer above it. And above the transport, we have the application. So the application layer is the one that's sending these messages. When the transport layer gets them, it will attach a header to the message, which contains control information for the transport layer on the receiving side. So all the connection, the tracking, the acknowledgements, all these things would be in that header. When the header is attached to a message, the message is called a segment. And then it will pass that down to the network layer. This here is the segment, or transport protocol data unit, or segment. So that contains some control information that transport layer on the receiving side needs in order to put the pieces back in the correct order, or to see if one of them is missing. So all of that information is recorded, different sequence numbers into the header, and we will see how this header looks like in details. So transport layer transport layer builds on the network layer functionality which is end-to-end packet delivery and provides data transport from a process on the sending machine. And when we say a process, we mean a running program or an application. So remember, it provides service to the applications. So the process is a running application. From a process on a source machine to a process on the destination machine with reliability. So the most important function of this layer is to provide reliability. So the ultimate goal is provide efficient, reliable, and cost-effective data transmission. To whom? Provide data transmission service to whom? Who are the users? These are the processes, right? They are running applications. To process an application layer. The software or hardware which provides these functions is called transport entity. We have two